In this video, we'll solve compound inequalities that are linked together by the term OR. So when we're solving these inequalities, the steps in getting x by themselves is really just like normal. The only difference is that when we graph the solution, it becomes a little bit more complicated. And that's because we have a compound inequality. We have a set of two inequalities rather than just one. So on the left hand side, I'm going to subtract 4 from both sides. I'm going to get 2x is greater than 4, divide by 2, and I get x is greater than 2. On the right hand side, I get negative 2x is less than or equal to 6, divide by negative 2, divide by negative 2, and I get x is greater than or equal to negative 3. So my solution is x is greater than 2 or x is greater than or equal to negative 3. What that means is that if I pick a number for x and that number fits either of those two inequalities, then that number would fit my compound inequality, would be a number that would fit the solution. So now I'm going to graph the solution to this inequality. So I'm going to start by graphing x is greater than 2. So that's going to be graphed by putting an open circle at 2 and then shading to the right, because the values greater than 2 are to the right. Now I'm going to graph the solution x is greater than or equal to negative 3. That's going to be a closed circle at negative 3 because it's greater than or equal to. And the values greater than or equal to negative 3 are to the right. So I'm going to shade over to the right. And what ends up happening is as I'm shading, I realize that that closed circle at positive 2 gets filled in. So that any of the values that are now part of my shading, any of these values to the right of 3, are solutions to this inequality. So my final solution is actually just x is greater than or equal to negative 3. But it's certainly appropriate for me to write it as a system or as a set of two separate inequalities. But I must remember to leave the OR linking the two. So let's try that again. This time with the inequality 2x minus 5 is greater than 5, or negative 3x plus 6 is greater than 18. So first I'm going to take the left inequality, I'm going to add 5, so 2x is greater than 10. I'm going to divide by 2, x is greater than 5. In the right inequality, I'm going to subtract 6, negative 3x is greater than 12. I'm going to divide by negative 3. Because I'm dividing by a negative, I need to remember to flip my inequality sign. So my solution to my inequality can be written as x is greater than 5 or x is less than negative 4. Now let's graph it on a number line. So my number line, I'm going to put 0 about in the center. Over to the right I'm going to put a 5. Over to the left I'm going to put my negative 4. Now as far as graphing the 5, I'm going to put an open circle at the 5, and x is greater than 5 is just shaded to the right. So I'm going to shade over to the right of the 5. For x is less than negative 4, open circle at negative 4, less than is to the left, so I'm going to shade those values to the left. So what this means is that my solution is a set of two shadings that never overlap. And that's okay, because for OR inequalities, the two shadings do not have to overlap. Anything that's shaded at all is part of my solution. So numbers like negative 6, positive 6, negative 5, 7.5 would all actually be part of my solution. Now numbers like 1, negative 2, 0, they actually would not be part of my solution because they're all not shaded.